Welcome Expo, this is Mr. Monahan for 11.4b. Today we're going to look at adding and subtracting fractions some more, but we're going to start to let the denominators be different. Okay, so that's our objective. It's to add or subtract rational expressions. So that's just, again, fractions with variables in it that have or with unlike denominators. So now we're going to talk about what happens if the bottoms of the fractions are not the same right away. And we're going to talk about how we've already looked at that when the fractions don't have any variables. So we just have a very similar process. Okay? In this first example, we have a review problem. I look at the denominators and they are the same this time. So this is a review from 11.4a. Up top, I can subtract the two things right away. So I have a 3x and a negative 12, since this is a minus sign right here. So up top, I have 3x minus 12. On the bottom, I have the same denominator there. But then we talked about simplifying this as much as we can. So up top, there's a GCF. 3 goes into both of those terms. On the bottom, we can factor this with 2 parentheses because this is a trinomial, a quadratic trinomial. I would put x in both of the first places. I have a negative middle term, a negative 9, and a positive c term. The only way to do that is with 2 minus signs. So two things that multiply to positive 20 that add to negative 9 would be 4 and 5. Now I have some things that will reduce. I can get rid of x minus 4s. So up top, we had a 3. On the bottom, we had an x minus 5, and that would be our answer. So when you're adding or subtracting, that's what you are looking for. Okay? Is the denominator the same? So let's look at one right here where the denominator will be different. So we've looked at this with no variables before, and this is something that you've done in previous courses as well. When you look at a fraction or a pair of fractions, a subtraction problem, and the denominators are different. We have a 6 and we have an 8. Okay? Those are not the same thing. So what do you need when the denominators are not the same? You need an LCD. What that is a lowest common denominator. Okay, so you're looking to find what's the smallest thing that 6 and 8 both go into. So for this one, if I was looking for an LCD between 6 and 8, you're looking for the smallest number that they both will multiply into. And a lot of times that's just by multiplying them together. But if you do that, you get 48. There's actually something smaller they both go into. They both go into, or the 24 is a multiple of both 6 and 8. Okay? So you want the lowest common denominator. So I want to make both of these denominators equal 24. So over here, this fraction, I need to multiply both the top and the bottom by 4. On this fraction, I need to multiply both the top and the bottom by 3. Because 8 times 3 is 24, and 6 times 4 is 24. All right, then I'll rewrite my new problem. Up top on the left, I had 4 times 5, which is 20 over 24, minus 3, 1 times 3, over 24. And what I'll end up with is 20 minus 3 up top, which is 17, 24 on the bottom, and 17 and 24 do not have any common multiples to reduce that fraction. If you start with the lowest common denominator, you should not have to reduce at the end, okay? With these types. Once we get into some of these other ones, maybe there's some factoring and canceling at the end. Okay? All right, so now let's put a letter into it. Okay, what is the smallest thing that 2x and 5 both go into? Well, at this situation, look at 2 and 5. The smallest thing that they can both go into would be 10. Okay, 10 is a multiple of both 2 and 5. It's the lowest common multiple. Okay, so then this x here, we also have to pay attention to because we need to have an x in both denominators, otherwise we won't have matching and we won't be able to add. So we look at 10x as our lowest common denominator, so I need to multiply both of these fractions by whatever would make the bottom 10x. So here on the left, I would multiply 5 times 2x, so I can multiply by 5 over 5. Over here, I'd have to multiply both sides by 2x, so that's what I'm going to do to both top and bottom. Okay, let's rewrite our problem. I have 5 times 3, which is 15, over 10x, plus 1 times 2x, which is 2x, over 10x. You can write it the way that it is. I know a lot of times we like to write in standard form, so variables first. 2x plus 15 would be on top. Since 15 doesn't have an x after it, I can't combine those into 17. They're not like terms. On the bottom, I have 10x. Okay. Remember, anything with a plus sign needs a parentheses around it. So in this situation, 2 and 15 don't have any common multiples, so I can't reduce that. So this is my final answer. I can't reduce anything because I would have to factor first, and nothing can be factored. Okay, that's level 1. Level 2, okay, we're to subtraction here. All right, looking at maybe what happens after we get everything subtracted. The lowest common denominator, let's look at the 3 and the 4 first. Okay, the smallest thing they both go into is 12. Okay, then whatever you have for x's on the bottom already is kind of what you want for that lowest common multiple. So the lowest common denominator this time will be 12x, not just 12, since I already have an x in the bottom there. So what do I multiply by these to get what I want? Over here I need to multiply by 4 to get 12, and then I need to multiply the x on there. So I'm multiplying by 4x over 4x here. On the bottom over here, I need to multiply 4 by 3 to get 12, and then I already have an x on that side. And look what happens this time. 4x times 4x, I get 16x squared over 12x. And then I have a minus sign. 3 times 3 is 9 over 12x. Okay, when I subtract those, there's no like terms here, but I do have something I can reduce because I have a lowest common, or I have something up top called a difference of squares. Okay, so 16x squared and negative 9 are both perfect squares, so this is that type of factoring we keep using kind of every once in a while, every day or two. Okay, this up top can factor because we can take the square root of 16x squared. We can use that as 4x times 4x. And then for 9, we can do 3 times 3. We can take the square root of both of those things. This is called a difference of squares. So I can do 4x plus 3 and 4x minus 3 as my factoring here. Okay, then so I factored. Now I'm just going to look if anything cancels out. Well, I don't have that exact same thing in the denominator anywhere. I don't have a 4x plus 3 or a 4x minus 3. I also can't make any of the numbers smaller at all to try to reduce the 12. So this is my final answer. But I do want to factor everything to see what might cancel. Okay. All right, next one. We have 2 left. So the lowest common denominator, look at the numbers first. The lowest common denominator, if it was just 2 and 3, would be 6. Okay, that's the smallest thing they both go into. All right, then over here I have an x squared. Over here I just have an x to the 1. I have to at least get the one on the left to be an x squared. I can't get rid of any x's, so I need to add x's until denominators end up being the same. Okay, so this one has to get multiplied by 3 to get to 6, and then it needs another x, so 3x over 3x. This one needs to be multiplied by 2 to get to 6, and then it already has x squared. Okay, be careful here, there's going to be some distributive property. All right, let's try that. Up top on the left, we have 3x times 1, which is 3x. On the bottom, we now have 6x squared. Okay, this is an addition problem. This is distributive property now, so 2 times x plus 1 times 2, which is 2, over 6x squared. Okay. Great. So then 3x squared and 3x and 2x, I'm sorry. These two, 3x and 2x, these will be like terms, which can combine into 5x. And then I have a positive 2 as well. On the bottom, I have 6x squared. 5 and 2 don't have any common factors, so nothing can be factored out. So this is my final answer. All right. Last one like this. Now we have 3 denominators that we need to worry about. So now we're looking at 3, 6, and 9 as our numbers on the bottom. Okay, well, 9 is in there, but it's also something that we could look at as lowest common denominator, but this 6 over here, 6 doesn't go into 9, so I have to go a little bit bigger. 6 goes into 12, but 9 doesn't. 6 goes into 18, and 3 goes into 18, and 9 goes into 18. So 18 is the smallest number that they can all go into. Okay. Then look at the A's. The largest amount of A's I have in the bottom already is A cubed, so that's going to be what I need in terms of how many A's I need on the bottom. Okay. So my lowest common denominator, is going to be 18a to the third. So that means I'm going to have some multiplying here. I need to multiply this one by 3 to get to 18, and it needs 2 more a's. It needs another a squared. Okay, so that's what I'm multiplying top and bottom by. This is going to be distributive property. Okay, this one needs to get multiplied by 6 to get to 18, and it needs another a. So this one's getting multiplied by 6a over 6a. And then this one, distributive property, needs to get multiplied by 2 to get to 18. And that's it, because it already has a to the third. Okay, so let's go through that. I'll write my answers down here. 3a squared times a, that's going to be 3a to the third. 3a squared times negative 4, that's going to be negative 12a squared over 18a cubed plus, okay, we have a 6a times 1, which is just 6a, over 18a cubed plus 2 times 7 is 14, 2 times negative 3a is negative 6a over 18a cubed. Okay, so now I'm at the adding step. We're going to put everything all together, 3a to the third minus 12a squared, okay, plus 6a plus 14 minus 6a. All of that is over 18a to the third, okay, but I have a positive 6a here and a negative 6a here that will cancel. So what I really have is 3a to the third minus 12a squared plus 14. All of that is over 18a to the third. Okay. Then I would look to factor if I can. Since this is an a to the third problem, I'm not going to be able to factor it the way we'd like to normally. So I'm not going to be able to do that. And then 3, 12, and 14 up top, no common factors there, so this will not have any reducing. Okay, we can try to factor it, but we can't. So let's wrap up what we said here. Let's just have a little bit of a conclusion. Steps for adding and subtracting rational expressions with unlike denominators. First, you want to find that lowest common denominator. Okay. Then you want to multiply each fraction top and bottom to make the denominators match. Okay, then you can add, subtract across the top. You never do anything to the denominators when you add subtractions. When you add fractions, the denominators stay the same. Then you factor, and then maybe there's some canceling. Sometimes there is, sometimes there isn't. So those are the steps. Once you have those steps written down, then you are free to take off from the video. Thanks for watching. Go ahead and give the assignment a shot. Good job.